Good morning, all. Hope everybody had a glass of water, hot water. Okay, shall we start the session? Yeah, metal oxide is formed when the metals react in air or burnt in air. They form metal oxide. Example, copper, when it is burnt in oxygen, it forms, or when it is reacted with oxygen, it forms copper oxide. Aluminium forms aluminium oxide, and aluminium oxide is amphoteric oxide as it reacts with both acid and base to form salt and water. And even zinc oxide, it reacts with acid and base to form salt and water. Hence those are called amphoteric oxides as they react both with acid and base to form salt and water. Okay, now everybody clear with my voice? Voice is audible to all? Okay, fine. Now, some metals will react with steam, and some metals or some metal oxides are soluble in water, and some may not react with the water. There are certain metal oxides which easily get dissolved in water, and such oxides are called alkalis. Alkalis are the metal oxides easily get dissolved in water. Which were those oxides? That is sodium oxide and potassium oxide. Sodium and potassium oxides are called alkalis as they get dissolved in water very easily. Okay, cleared? Okay, I'll share the screen, and at the time you may have some little bit break in my voice. Okay, so let me share the screen. So these are about physical properties of metals and non-metals. This is air, it forms metal oxide. Copper forms copper oxide. Aluminium forms aluminium oxide. Look at this example. Aluminium oxide reacts with acid. In the same way, aluminium reacts with base to form the salt. Aluminium chloride and sodium aluminate. These are the salts formed along with the release of water. Hence, aluminium oxide, zinc oxide are called as amphoteric oxides. Look at this. Sodium oxide, potassium oxide reacts with water, and hence they are called alkalis to form respective alkali products, that is sodium hydroxide, potassium, dissolved in. Now this is one more example how the metals react with water. Previously we come to know how metals react with air to form oxides. Now when metals react with water, it forms metal oxide and even metal hydroxide. Remember, when metal reacts with water, it forms metal oxide and metal hydroxide. Look at these examples. When potassium reacts with water, it forms potassium hydroxide and hydrogen gas is released. When sodium reacts with water, it forms sodium hydroxide with the release of hydrogen gas. Why? The potassium and sodium are so reactive, easily they get reacted with water and air. And when it is reacted with water, it releases hydrogen gas. And one more example, when calcium reacts with water, it forms calcium hydroxide and again it releases hydrogen. Now look at this example. When aluminium is reacted with water, it forms aluminium oxide. Along with that, it releases hydrogen gas. Iron, when it is reacted with hot or cold water, it forms iron oxide plus hydrogen gas is released. Remember, lead, copper, silver, gold do not react with water as they are very less reactive, stable compounds, and hence they doesn't react with water. And we know that lead is very less reactive metal, and copper, silver, gold are noble metals as they occur in natural state. Okay, now all of you gone through the concept how the metals react with air and how the metals react with water. Okay, now tell me, when metals reacts with water, what products are formed? When metals reacts with water, what are the products formed? Yes, it's metal oxide and hydrogen. Very good. Okay, Kirti, Arpita, when metals reacts with oxygen, they form metal oxide. Okay. So you're supposed to answer metal oxide plus hydrogen. Okay, Arpita, but don't give half of answer. Okay. Yes, Gayatri, correct. Who is under name Guru Prasanna? Yeah, Rekha, correct answer. Remember always, when metals reacts with oxygen, it forms metal oxide. When metals reacts with water, it forms metal oxide and hydrogen gas is released. Or if you have any queries, let me clear here only. Okay, if it is clear, shall we move on? Okay, I'm not getting any reply. Okay, I'll move on. Okay, this is reactivity series. Yesterday we had thermal conductivity and electrical conductivity series, and this is reactivity series. Both are different. Thermal conductivity and electrical conductivity, high and lowest elements are different. Reactivity series, high reactive and low reactive elements are different. Okay, so when the questions asked, be alert, think over it and answer. Now, as per reactivity series, potassium is highest most reactive element, and gold, platinum is considered to be least reactive metals. Remember, potassium is highly reactive and gold and platinum is least reactive metals. This is about reactive. You should know hydrogen, copper, mercury, silver, gold. Now, which is highly reactive and which is low reactive? If you have this idea, it will be very helpful while deciding the displacement reactions. Okay, now tell me, Which is most reactive metal and which is least reactive metal? Yeah, potassium is considered to be most reactive metal. Reactivity series. I already told which is an most reactive metal and least reactive metal. Yes, correct, Gayatri. It is potassium most reactive and gold less reactive. Yes, Pallavi, correct answer. Yeah, Arpita, half answer. Kirti, lead is very weak in thermal and electrical conductivity. Okay. In reactivity series, okay, it can react, but not as much as potassium and sodium, but it undergo reaction. Okay. Now, Kirti, the second part answer is wrong. Yes, Priyanka, your answer is correct. And Arpita, answer is incomplete. It is confusing. Yes, Varlakshmi, correct answer. Yeah, Bhargavi, gold is less reactive. Okay, if it is clear, we'll move on to the next concept. How do metals and non-metals react? We know the metals are always donates the electrons in order to attain the octet structure. Each and every atom has K, L, M, N shells, and when the shell outermost shell, if they want to attain octet structure, they donate the electrons and sometimes the elements receive the electrons. And always it is metals will donate the electrons and non-metals will receive the electrons. So metals attains plus and non-metals attains minus charge, and thus the atoms becomes ions. When the metals loses the electrons, they gain plus charge and they are called ions. And in the same way, the non-metals receives the electrons, they'll get minus charge and thus they become ions. When any atom loses the electrons or gains the electron, then they are called as ions. Okay? Oh, Kalpana, it's very late today. Okay, morning to all. Now, all of you cleared with how the ions are formed, why the metals attains plus charge, why the non-metals attains minus charge. Was that clear? Okay, my simple question. Now, which elements loses the electrons and which elements gains the electrons? Quote with an example. Which elements loses the electron, which elements gains the electron? Quote with an example. Okay, which elements loses the electrons and which elements gains the electrons? I'm not getting any reply from your side. It's so easy. Quote with an example. Very good at reply. Nandini, Revati, Varlakshmi, Pallavi. And Pallavi went something wrong. No, Nandini, copper is correct. Copper loses the electrons. And chlorine receives the electron, correct? Okay, now I'll share the screen. Just have a look on that. Sodium, whose atomic number is 11, and KLM, M shell has 1 electron, and chlorine, sodium has got 1 valence electrons, and chlorine, if you look at the electronic configuration, 287. 7 is the outermost orbit electrons, and they are bulky, they cannot move. Whereas sodium has got only 1 valence electrons, easily it can be removed. So sodium donates the electron and chlorine receives the electron. And thus sodium chloride is formed. Look at the right side. Sodium attain octet structure 2 and 8, and even chlorine 288. Even this also attained octet structure. In a given example, the sodium and chlorine, they are attaining the octet structure by donating the electron and by receiving the electrons. As a result, they converts into ions and sodium chloride is formed, that is ionic compound. Sodium chloride is an ionic compound. How ionic compound is formed? When ions are formed, ions, by losing the electron and by gaining the electron, thus a bond is formed, and thus those compounds are called ionic compounds. Okay, cleared with example. Sodium chloride, how it forms ionic bond. Okay, now we'll go with one more example. We'll go for one more example, how ionic compounds are formed. Okay, I didn't took image. Magnesium, which is an bivalent. Okay, instead of sodium, you take down magnesium, and in the chlorine place, as it is chlorine, And magnesium is a metal which donates the electrons, and chlorine, it is a non-metal which receives the electrons. And magnesium is bivalent, chlorine is monovalent. Now, magnesium chloride is formed, and what is the molecular formula for magnesium chloride? Okay, just now I quoted magnesium is a bivalent, chlorine is a monovalent. And how the magnesium chloride is formed? What is the molecular formula of magnesium chloride? Yes, Priyanka, absolutely correct. It is MgCl2. Mg is 2 plus, Cl minus. So in order to balance 2 plus, 2 chlorine atoms will get attached so that magnesium chloride is formed. Here in the study material, page number 48 and 47, we have dot structures. Dot structures are nothing but denoting the number of electrons in outermost orbit. And this is very important for your examination. They'll ask dot structures. They'll ask dot structures. So please practice on this. Yes, now everybody answered correctly. Magnesium chloride, MgCl2 is the right answer. Now observe the dot structures. Sodium has 1 dot. Chlorine has 7 dots. And sodium donates the electron. So in the right side, sodium has got plus charge as it donated the electron. And the chlorine received the electron. You can see black and blue dot. When it receives the electron, it attains minus charge. In the right side, they are the atoms. Left side they are the atoms. At the right side, they are the ions. This is how you are going to represent the dot structures. Okay, we come to know that how ionic compounds are formed. When metals donate electrons and when nonmetals receives the electron, they attain charge, and charged particles are called ions. The charged particles are called ions. Now, what are the important features of ionic compounds? They have high melting and boiling points. They are solids and they are brittle. Solids and they are brittle in nature. And they are good conductors of electricity in aqueous state. They are good conductors of electricity only in the aqueous state, in a molten state, but not in a solid state. When they are in the solid state, they don't convert into ions, they remain as compounds. But in a molten state, they convert into ions and hence they can conduct electricity. Okay, Manasa, again you changed your mobile set. Okay, all these days, Triveni, by Triveni you just entered, and now Manjula, and the name Manjula you have entered. Okay, all of you cleared with ionic compounds properties. Ionic, the charged particles are called ionic compounds, are called ions, and they are solid in state and brittle, hard. They have high boiling and melting point. They are soluble in water and insoluble in kerosene and petrol. They are insoluble in kerosene and petrol. They conduct electricity in molten state but not in solid state. Hope everybody cleared with this. Okay, if it is clear, shall we move on? Occurrence of metals and metal extraction. Now there is the flow chart showing metals of high reactivity, medium reactivity and less reactivity, and how they are extracted. Now elements or compounds that occur naturally are called minerals. The minerals with impurities are called ores. I'll repeat. The elements or compounds which occur naturally are called minerals. The minerals with impurities are called ores. Okay, what are minerals? What are ores? You just be typing. I'll be back within 5 minutes. Okay, all of you typed the answer. It was almost correct. And here and there some words are left. Okay, now the naturally occurring elements in the earth crust are known as minerals. The minerals with impurities are called as ores. Now, the ores has impurities and they are the mixture of metals, non-metals and impurities. And now we want to extract the metal from the ores. And how to extract the metals from the ores? It is based on the reactivity of the metals. Now we know that they exist in ores. That means with the combination of nonmetals and impurities. We have to separate the metals. Now example, gold, silver, platinum are existing in a free state. They are less reactive. They don't undergo any combination with other elements. So they occur in a free state. Hence they are called noble elements. And some metals like copper and silver, they have some oxide forms. And these oxide forms should be reduced to separate the metals. Now how to separate these metals? We have a flow chart. Let me go through the flow chart. I'm going to share the screen. Okay, this is the flow chart. Concentration of ore is a method where we can separate the impurities from the ore, and such impurities are called Ganji. The Ganji is separated, then we concentrate the ore only with the metals. We remove almost the impurities by concentration of the ore. And how to concentrate the ore? It is based on the reactivity. The metals of high reactivity always subjected for electrolysis in a molten state to get pure metal. The metals of medium reactivity will have two options. If they are carbonate ores, then calcination is done. If they are sulfide ores, then roasting is done. So that by calcination and roasting, the ores convert into oxides. And those oxide of the metals should be reduced to purify the metal. And the metals of low reactivity, that is sulfide ores. The metals of low reactivity always subjected to roasting, and thus will get the metals. This is how we separate the metals from its ores based on their reactivity. Okay, now how the metals of highly reactive elements are separated. Now which is the method used to separate the metals of highly reactive? Venuka, why you were absent for these days? Yesterday you was not there in the school. Huh? No assignments? You didn't even submit assignments? Good morning, Venuka, but tomorrow there will be test. Get prepared for the test and come with your assignments. Okay, Venuka? Okay, I'm not getting any reply. How the metals of high reactivity get separated? Yes, it's Priyanka answered electrolysis of molten ore. Correct answer? Okay, fine, Venuka. Don't get absent because only 4 months are left over for exam. Please, all board exam students, don't lose the classes. Either it is live class or regular class. Okay. Okay. Electrolysis of molten ore is the correct answer. So this is the best method for highly reactive metals. Okay. Then how the carbonate ores, the metals are separated. How the carbonate ore metals are separated. How the carbonate ore metals are separated. Why no one answered? Okay, Venuka, that is for previous one for metals of high reactivity. Now my question is how the carbonate ore metals are separated. All of you audible? All of you audible? Okay, I didn't get any reply from your side. I don't know, it's not a tough question, it is so easy. But still, no one answered. Or any network problem? You are not hearing me? Okay, the answer is calcination. Calcination is a process where the carbonate ore metals are separated. And how the sulfide ore metals are separated? No, Kirti, I need the method. which is the method used to separate the metals. Now, how the sulfide ore metals are separated? Yes, it's by roasting. Very good, Priyanka. All carbonate ores metals are separated by calcination. I already gave the clue. Carbonate C and even calcination C. Keep in your mind C with C, okay? And for sulfide, there is no such technique. Sulfide ores metals are separated by roasting. By calcination and roasting, it is just converts into oxides. And again, the oxide forms should be reduced to convert into pure metals. Remember, the oxides should be reduced to convert it into pure metals. Okay, now we will go with the example. Okay, this is how we can extract the metals by the methods: highly reactive electrolysis. For medium reactivity, it is calcination and roasting. And for noble metals, they occur in native state. And less reactive ores can be separated by roasting. Now this is extracting of metals with low reactivity series. Now the sulfide of mercury is roasted as they are less reactive, subjected for roasting in presence of oxygen. They convert it into oxides of mercury and the sulfide gets separated as sulfur dioxide. And again, the oxide of mercury is reduced to form mercury and oxygen. Okay? This is the equation. Cinnabar, the sulfide of mercury, is otherwise called cinnabar. It may be asked for 1 mark. What is cinnabar? The ore of an mercury. Cinnabar is an ore of mercury. By roasting, we'll get mercury, pure mercury. The second example, even the copper sulfide, when it is roasted, it converts into copper oxide. And by heating, we can separate copper, which is a pure metal. And what is this copper sulfide commonly called? Chalcocite. Cinnabar is sulfide of mercury. Chalcocite is copper sulfide. Okay, chalcocite, cinnabar. These may ask for 1 mark questions. This is the equations represented with low reactive ores. Same example, cinnabar and chalcocite. And these are the metals of medium reactivity. And medium reactivity series usually separated by roasting and calcination. Now examples are zinc sulfide undergo roasting to form zinc oxide, and the zinc carbonate, which is a carbonate ore, and here instead of roasting we'll do calcination. What is the difference between calcination and roasting? The sulfide ores converted into oxides by presence of excess of air is known as roasting. I repeat, the sulfide ores are converted into oxides by heating in the presence of excess of air is known as roasting. Ore changed into oxides by limited air is known as calcination. I'll repeat. Carbonate ores. The carbonate ores changed into oxides in limited air is known as calcination. Okay, these two questions are important for your board exam. Look at the example. Zinc sulfide subjected for roasting. Zinc carbonate subjected for calcination. In both the cases, they converted into oxides. Now, after oxides are obtained, now zinc oxide is reduced in presence of carbon. The zinc oxide is reduced in presence of carbon to form metallic zinc. This is how the medium reactive ores are separated. Hope everybody cleared with less reactive and medium reactive ores and how the metals are separated from it, right? Now, could you be able to give example for less reactive ores? Which were the less reactive ores? Give me example. Okay, give me example for less reactive ores. Okay, so lead, cinnabar and chalcocite are sulfide of mercury or copper sulfide are the less reactive ores. Now give me example for medium reactive ores. Yes, Nandini answered cinnabar. Very good, Nandini. Very good. Good answer. Okay, very good answer, Priyanka. Cinnabar and copper sulfide. Very good. Okay, now tell me, now give me example for middle reactive series. Give me example for middle reactive series. Yeah, zinc sulfide and zinc carbonate. Okay, Priyanka, zinc sulfide and zinc carbonate, because two examples are given in your material, and also now just I discussed on two examples. Zinc sulfide undergo roasting, zinc carbonate undergo calcination to form zinc oxides. zinc oxide is reduced with what? The zinc oxide is reduced with? How the zinc oxide is reduced? Yes, now it's corrected. Good, Priyanka. Aishwarya, what is the spelling for zinc? Yes, Bhargavi. Shubha, correct answer. Yes, Sandhya, correct. Yes. Now it's carbon. Now zinc oxide is reduced to pure metallic zinc, that is by carbon. Very good, Priyanka. No, Aishwarya, it is not zinc and sulfide. It is only one word, zinc sulfide and zinc carbonate. Yes, correct, Varalakshmi. It is zinc sulfide and zinc carbonate. Okay. Now, the last one, how to extract highly reactive metals. Now, the highly reactive metals like potassium, sodium, calcium, aluminium, they cannot be separated easily by roasting or calcination as they are highly reactive. So, how we can separate those highly reactive metals? It is only by electrolytic reduction. It is by electrolytic reduction. Now look at the example. Electrolytic refining setup is there where anode and cathode rods are inserted in metallic salt, which is used as an electrolyte, and always the cathode is made pure rod, made with as a pure rod, and anode as a fixed with the impurity mud ore. Now when electricity is passed, the electrolyte solution conducts electricity, and thus from the mud particle which is left over at the anode, the metals starts moving towards the cathode. As the cathode is mainly made up of pure plate, the metal deposit on the cathode remains very pure. Thus, the highly reactive metals are separated by electrolytic reduction or by electrolytic refining. Even we can apply this for copper, zinc, tin, nickel, silver, gold, as they are very expensive. So we extract these metals from same electrolytic reduction or electrolytic refining. Okay, all of you cleared with how the metals of highly reactive series are separated? The highly reactive metals are separated by electrolytic reduction or electrolytic refining, where a electrolytic chamber is fixed, where anode and cathode is kept connected to the battery, and metallic salt is used as an electrolyte, and anode is made with the ore, impurities mixed ore, and cathode is made as a pure plate. Now when power is connected, the metals usually move towards the cathode. Metals are obtained by electrolysis or electrolytic reduction or electrolytic refining. Hope everybody cleared with how the metals are extracted. This chapter is so important for exam. Not even a single line is deleted. Complete chapter is meant for your examination. Okay. Now I'm going to include this chapter for tomorrow test. Now go through this chapter also. Okay. And now last concept is corrosion. Already we discussed in the first chapter. And first chapter has been removed for the purpose of examination, but the concepts like corrosion is still retained. Okay, you want to go through the corrosion. What is corrosion? Sometimes the metals are eaten away by the activity of oxidation or with reaction with acid, salts, water, and oxidation. Now, when iron reacts with water, it forms rust, even that is corrosion. When silver particles reacts with sulfur, then it forms a black coat. And the name of the black coat is silver sulfide. Silver sulfide. In the same way, the copper reacts with carbon dioxide and forms green coat. What is the name of the green coat? It is copper carbonate. When iron exposed to the moist air, it forms a brown flake substance, and that is called rust. These three important points are there for your examination. Silver particles combines with sulfur to form silver sulfide. Copper reacts with carbon dioxide to form copper carbonate, green coat. Iron reacts with air or water to form a brown flake, that is called rust. So these are corrosion. These are called corrosion. How to prevent corrosion? It's very simple. By galvanizing the articles, by painting, oiling, greasing, the last concept I left here is thermite reaction. What is thermite reaction? The reaction of iron oxide with aluminium. The reaction of iron oxide with aluminium used to join railway tracks or cracked machine parts, and this is known as thermite reaction. This is also important for your board exam. And tomorrow I'm going to ask this question also. A reaction of iron oxide with aluminium used to join railway tracks. Okay, this completes the chapter. Okay, tomorrow for the test, what you are supposed to read and come. No need to go for first lesson. Second lesson till the pH importance. Complete till the pH importance. And in the last go through. And metals and non-metals, complete chapter. Complete chapter you want to go through. Okay. These three chapters are meant for tomorrow test. All the best. Go through this videos and the textbook repeatedly and get ready for tomorrow. Okay, all of you. Thanks for visit and very good response. Soon. Thank you. Thermite reaction. Okay. Okay, if it is cleared, thank you one and all. See you all soon.